Good morning, good afternoon, good evening. Welcome to another episode of Hands on SAP Dev with me, DJ, and Patrice Bender from the Cap Compiler team. Good morning to you, Patrice. How are you doing?
I'm doing great, DJ. Friday again.
Friday again. Here we are again. In fact, Patrice and I were just chatting as we were setting up, and I was making my cup of tea, and Patrice was getting his coffee. This is likely to be the penultimate episode, so we'll have another episode next Friday as a wrap up. So make sure you attend that one as well. But anyway, good morning, good afternoon, good evening to everybody. Thanks for joining. Oh, I was going to say, oh, good morning, Patrice, but obviously in the chat there, I'm reading the chat. Patrice 42. Nice. Chiara, buongiorno to you, and Helmut. Good morning to you in Braunschweig in Germany. And Johannes, we were just talking about you as well. Welcome. And Ulrich, another old friend of the Hands on SAP Dev Show. Welcome. Great to see you online. Everybody's welcome. So, without further ado, let me just give a quick summary of what Patrice covered last Friday, just to sort of get our brains in gear. I mean, Patrice started out with this complicated phrase association like calculated expressions, and the complication sort of belies its beauty and power because we saw how an existing association could be then used with an infix filter as to define another element, which like blew my mind. And so this sort of this was an amazing revelation to me, as was also the understanding of how the two different ways we can define a calculated expression, as in an element position, either with or without the type definition, the cast. That's sort of what I think of the casting. And basically, if you don't define a type, it defaults to string. It wasn't anything to do with sort of inference. I've got my notes here, so I'm going to read through my notes. Oh, here we go. Yes. So Neil asked a great question about the effect on various constructions, query and expression constructions on large data volumes. And Patrice gave a great answer here, which basically boiled down to, use the tools that we have, i.e. the 4SQL for us to have a look at the cap style SQL and also the 2SQL and just be aware of we have this abstraction layer between what we can write, the beauty and the concision or the conciseness of what we can write in CDS generally, with what actually CAP, the framework, does for us. But it's also great to be aware of what these constructions become, whether that's a subquery or a left join or a combination and so on. And so, data volumes are important, or these things are important to think about when we have large data volumes and so on. And also, I think we revisited one of the best practices, concise, small service definitions that do only what you need and no more. Because services are cheap, that's an axiom as well. The amazing meat of the part for me was where we had the exists, which of course, when we first saw it, became or was reified in the form of a subquery, a subselect, which then just returned column value one, as in, some sort of, literal scalar value, as in a yes or a no, effectively. But when we then added path expressions to the query, that sort of negated the effect, the beauty and the effect of those of that subquery because a left join was necessary, and then we went back from a normalized flattened output with single non-duplicates back to duplicates because we had to do a left join. And then that was the backdrop for Patrice to introduce to us the concept of nested expressions, where we also don't get a flat non-duplicated structure, but what we get is, flat non-duplicated output, but what we get is a structure with nested data, which is sort of a little bit odd when we think about what SQL is really all about at the bottom level. However, then Patrice went to show us that the reason this is possible is because of the JSON functions that the underlying databases support, and the use of those JSON functions that the team, including Bob and co, have built in to make that possible. So
Perfect.
that's pretty much it. So over to you, Patrice. In
Thanks,
fact,
DJ.
I'm doing exactly what my friend accused me of. She watched the intro to last Friday's, and she said, "DJ, you don't half ramble." So I've tried to keep it more concise, but I'm rambling now, so I'll shut up. Patrice, go for it.
Yeah, thanks for the introduction. I appreciate it. I think it's just worth reiterating over the stuff we learned in the last episode, so that we have a nice foundation to build upon. So I think you're doing a great job there. So I hit share.
Yes.
So chat, if anything bugs you, if everything is too small, just let us know. If you have a question, let us know. Try to answer them right away. Or if you have, things for us to try out, you can just shoot it.
We love your
This
questions.
is, either we do it this time or in the next, presumably last episode. So yeah, take the chance. Yeah, so last time, what do we do? We had a look at the CXL documentation once again, which you all know by now, right? So we looked at the big syntax diagram which we have for the general expression here, which had a nice facelift. So I think it's beautiful now, like really fitting to small screens also. So really nice thing to look at, in my opinion.
Mm-hmm.
And in the last 5 episodes, we covered everything here, actually. So in the first episodes, we began with the literals, the functions, and the operators, right? We then progressed to, predicates, right? Like the between and the in predicate.
Mm-hmm.
And we also covered exists, the case when statement, and last but not least, and probably the topic which we could talk for ages about, is the whole topic of path expressions, right? Which we dived into gently, I think, in the 4th episode. And then last week we had a deeper look into different kinds of path expressions, right? So if we check out what a path expression is, just to reiterate on that as well, it's just a reference basically to an element. It could be as simple as having, you can see we have some examples down here. It could be as simple as just referring to an element. This is also like an expression, the most simplest variant of it, just being
it's just
scalar.
A leaf expression, right?
Yeah, it's a leaf element, right? So basically a scalar type, nothing structured, no association whatsoever. And the cool thing about path expressions, right, in CDL in general, is that you can chain navigations together. Like, for example, the associations, right? You can just walk over to other tables and query associated data, which you have the possibility to, because we have kind of declared the join in a forward declared way in our model beforehand. And then once we use it, it materializes somehow into something, right? It could be an exist subquery, it could be a left join, it could be a correlated subquery for the expanse we had a look at last week. So very powerful construct. And we will dive deeper into this today. And we also learned that we can use it basically everywhere, right? It could be in a calculated element in your CDL model, or it could be in an annotation expression, for example, for the assert. If you want to learn more about that, rewatch episode 1 and 2. There we talk about the assert annotation, which can be used for dynamic input validation. Awesome feature. And besides that, you can also use CXL, so the expression language, in CQL, which is the query language, right? So throughout the sessions, we mostly use CDS REPL to fire queries against our database services. And this is the CQL language, so the CDS query language. And in there, you can use path expressions, right? So in your column list, in a where, in a group by, and so on and so forth.
Yeah.
Right? So last time we had a look at the non-seller, as DJ reiterated, right? The association-like calculated element, which we used in different situations. So we were able to use this in a exists after the exists predicate, or with the exists predicate, to put it, and also in the column list, right? To either do the dot notation thing to navigate to an element of the books, which resulted in the left join. And we also had then finally a look at using this to expand to get some structured data back.
Yep.
So maybe we'll do a quick REPL session so I'm still in my bookshop, right? So what happens there? Okay. So we're now in the REPL, and I will just now show you some basic examples which we had last time. So again, I can in there, right, use all the CAP APIs, for example, CDSQL, to just play around and fire queries against the database services. So in here, we had last time, for example, we selected from the authors the name, but only those authors which have like a non-seller, right? So
I mean, that itself blew my mind, that we could use this association-like calculated element as effectively a predicate condition in that exists. It's crazy.
Yeah, that's right. So yeah, we were able to use it just as any other element, right? And when we had a look at the resulting, so in the right, remember we have the query, which is basically our CAP style query, our CAP style way of writing things, which results in this basic CQN here, very comprehensible. And we were also able to inspect what's going on there with the for SQL command, right, to get a SQL style normalized version of this. And then we noted that we have in here a subquery, which has the non-seller attribute as table alias. So I have enabled now the technical table aliases. So it's a little bit shorter, but not human readable. So let me maybe quickly go ahead and change this again. So
we're getting a little peek into some behind the scenes here, which is always awesome.
Yeah, well, I am working on a version which enables this with an environment variable so that you can have nice debug output, right?
Beautiful.
But we just keep it to a minimum here and use like technical table aliases. So this gives you in some cases less ambiguities. So so don't do what I do now, but I will just give you a glimpse of what's going on here. So we have utils here, and there's this function get explicit alias, right? And there's this use technical alias function, and I can just say the default is now false, right? So
nice. And a documented function. Nice, beautiful.
Yeah, so I'm working on overriding this in a way that we have this available for you. And now you see we have the non-seller association here as a table alias. So what I take from this is, if we have a query like this one, we can use an association just like a table alias. So like just another table, right? Which is a cool thing.
Yeah. And so I know you were explaining that was CQN and everything. And just as a reminder as well, for me as well as other people, maybe the 4SQL produces CAP style SQL, and the clue that it is CAP style SQL is that there aren't any subselects or joins. We're still at the level, the sort of abstract SQL level, where we see the path expressions written out as elements in an array.
That's right. That's right. So, and the thing here was, right, if we send this query, Oop. So like this. Okay, I messed something up here. Give me a second. I think I didn't patch what I just did. Didn't do the right thing, so I will revert it for now.
That's okay. We always learn from things going wrong, so it's always good.
That's all right. I think, yeah. So
I like the use of the dollar as a prefix. There's a bit of a nod to Perl, which in turn is a bit of a nod to Orc as well. So two beautiful languages from the good old days. So yeah, nicely chosen.
So yeah, I mean, I can talk a bit about why we use those technical aliases, and it also, I think it's a nice thing to understand here.
Absolutely.
So we have sometimes in our CDL models, right? We have, for example, the genres entity, which is the perfect example for this, which is basically a recursive structure,
Yes.
right? So we have genres. I can query them real quick, and genres have parents, right? Or one parent, to be exact.
Yeah.
So, and this goes on and on, right? So there are multiple levels of genres, and it's a recursive entity. And if you think about it, if we do stuff like this, I can introduce you to a concept, which is I call it scoped queries, right? It's also a kind of path expression. So I wanted to talk about that later on, but I think it's a good thing to note now, is we can also traverse the on condition, the from clause, right? With some paths here. So for example, what I do here is, you noted probably that we have the colon as divider for our path expression. So I go from, so you have to read it like this, right?
Yes.
So I select parents now that have a genre, right? So I correlate the parent with the genre here. So this is, yeah, and you can go on and on. So you could say, I only select those parents
the grandparents
that have a parents, right? And now I only select the grandparents here. And so you can chain that, right? I can query that. So we only have those three guys now as a result here for being the parent genres, right? And this under the hood translates also to where exists subquery. Oop. So I have to use the
injected
variable here, and then you can see it's just the where exists subquery here, which happens under the hood. So it's a nice syntax variant of writing something like this, right?
Wow.
Okay. And now think about it. I wanted to talk about the alias name. Okay. So now we assign explicit alias for our path expression here. And now we have the genres parent as parent. And what we can do now is, for example, we can use this table alias to navigate to the key of our current query. So the thing is, in SQL, the very first step of a path is always resolved first as a table alias and then as a element reference. So if you look at the left-hand side, we have an association, which is also being called parent, which is the same name as we have now for our table alias.
Yeah.
So question to you, DJ, what happens now? What will the parent ID be resolved to?
I'm guessing, well, because of the modification you're doing to that function, I'm guessing it might be to the alias.
That's right. That's right. So we have our reference here, right, in the columns. we have the name and the parent ID. And if we look at, we just check out the result now.
Mhm.
You can see we get back 3 times the ID of the genre itself, right?
Yeah.
But what we could also do is, so the parent was obviously was the implicit table alias here for the name, for example,
Yes.
was also the parent. So our result doesn't change, right? And what do we want? So if we want to have the foreign key now of the parent entity instead of the ID of our current result, we would have to do parent.parent.id.
Yes.
And now you see we get back a parent ID for our biography, because this is the only genre which has another parent here. So,
yeah,
right? And the other IDs are null because they have no more
top level.
parents.
Yeah.
Right? So the reason for us using the implicit alias, so the technical aliases, is that we want to do not confuse users with the technicalities of this, right? Because we assign an implicit table alias which does not collide with any, so which is less likely to collide with any element
Right.
reference in here. So this is what users expect, right? So if I leave out the explicit table alias now, as in the first example, right, you don't have to know about internal mechanisms because we just do a technical table alias, and then you can just traverse as you wish in here.
Gotcha.
So this is the reason. So this was a little excursus here. Recursive associations in combination with scoped queries, right? So
I'm already thinking I'm going to have to watch this bit back again, because this is not only recursive associations, but also on top what you've just shown us with the aliases.
Yeah, it's just a SQL. So we try to stick as much to SQL as possible, and
Right. Yeah.
we try to really do the name resolution properly. And the first step in any path is always try to be resolved as a table alias first, right?
Yeah.
So this is the whole reason for technical table aliases. But I see that it's nice for debugging purposes to have it nicer, right? So I'm working on that to have the more fluent table aliases. So stay tuned on that.
Brilliant.
So let's have a look at another example we had last week. It was the expand, right? Where we had where exists to the non-seller again, and then we also expanded to all the non-sellers of the authors, right?
Yeah.
So we select all the authors which have non-sellers, and then also display the non-seller books, right? And then we get this list back here. So, and the cool thing about the using the expand syntax here, the nest really what is just another postfix projection, was that we were able to use stuff like a star or excluding, just as it would be the top level postfix projection of a query, right?
Yeah.
So we were able to do a non-seller wildcard select, and then we could, for example, exclude the ID from the result, and voila, we get back so here JRR token, right? And we get back the non-sellers with all the fields without the ID, right? So, and the cool thing is we have a little sibling of the expand syntax, which is another variant of a postfix projection, so to say. And it comes in handy if you have similar paths, I would say, in your queries or in your views. I will now jump over to the catalog service in our bookshop to showcase what I mean. So I think this is a good thing to plug in. We have the books projection, right?
Yep.
Which includes all the fields of the books with the wildcard, and then also the author name. And I could obviously extend this path what this column list by traversing to another field here. For example, I'm interested in the date of birth, the author, right?
Yes.
So one
And I think
possibility.
we've seen this sort of approach because we've been spending a lot of time at the schema level, the DB level, let's call it. And now obviously we've moved up to the service level. And
Right.
I've seen this in a really nice example as well in one of the Capire samples on GitHub I think from probably Daniel, where the idea is not to expose the two related entities that comprise this bit of data. So if we didn't want to expose the authors explicitly or even talk about the authors, what we're doing here effectively is flattening that relationship into just a single set of rows. Is that fair to say?
Yeah, it is. I think that I remember the example you're talking about, and
I think it might have been in
all.
Capire Common.
Yeah.
Oh no, X Flights.
Oh, okay. The new S-Flight version,
Yeah.
the lean S-Flight, so to say.
Yeah.
I see. So what we did here now is, right, we extended the column list with the date of birth of the author. And I think it's worth to have a look at what's happening behind the scenes again. So I just built the model now this time, right, which is like the equivalent of the normalized CQL, which we have seen in the REPL, right? But basically, no, it's the two-SQL channel already, right? So we see the resulting SQL based on this CDL view here. Let me check where it is. It is the catalog service books HTTP view. And you can see in here, we have in line 7, we have the author name as author. And we have in line 12, we have the author date of birth, right?
Yep.
And what you can see now here is, and again, the compiler also uses technical aliases, right, to have some less ambiguities in here, at least when it comes to the joins, right? So what you can notice here now is that the name and the date of birth are using the same node, the same join node, right? Being the left join to the authors in here.
Yes.
So they are both like fetched from the same set because they use the same join and the same condition basically to match the records of the authors. And what we can do now is to get the same result, but with a little, I like it at least. So you have to decide if you want to use that syntax, but I like it with a little less boilerplate code, in my opinion, because we repeat the author association here, right? We could also do stuff like this. We could, with the dot notation, open curly braces, and then we have another projection in here. And now we are in the context of the authors. And I could say name as author in here, for example, right? I will just say name because of duplicates here, I guess. So we will say select the author name and also the date of birth in here. So what we do now is we use the author association to traverse to the name and the date of birth. And this is not to be confused with the expand, right? Where we sort of have a structured set back. This is just a shortcut notation for having like a summarized conscious path expression in here.
There's a very similar construct in JQ, in fact, that you can do exactly the same thing. So basically to be concise and refer to multiple children, there's a very, very similar idiom in JQ.
That makes sense, right? So I think you can group your related path expressions together, and it's a good thing for others, also for you, for maintainability and all that stuff.
Could we add aliases within this nested construct here as well?
Yeah. So let's have a look at. So you can do everything what we learned in the basic projections, right? You could use an excluding here. I mean, it doesn't make sense now because we don't have
Yeah,
a
put it in
wildcard
and then take it
select,
out.
right? We don't have a wildcard select. Maybe we can have a look at that later. But let's first have a look at what changed in our catalog service books, right? Not much, actually. I mean, we now have the date of birth as birthday, right? In here. And you can now see we have just another left join generated for our inline path expressions here, which are just, you know, a nicer way of writing things.
Beautiful.
In my opinion.
Yeah, that is really nice.
Yeah. So good thing to know. And also what you can obviously do is, and this will probably be the topic for the rest of today, we will talk a little bit more about infix filters. And you can, for example, also use the infix filter notation to further narrow down our result here, right? So what could we do here? Everything, basically. We could say, yeah, we want to have the author's name and date of birth only for those authors which have books written. Okay, they have obviously all written books, right? We are in the books a projection here, but we can also make it a little bit more spicy and add another.
That is definitely spicy. That is definitely spicy.
Right. Maybe it's okay. Empty filter, says the compiler. Yeah, just keep calm. I will add a filter now. So now we should get back so we get null values back for those authors for which this condition does not hold, right? But the important thing is we have added like arbitrarily complex filter condition to our nested projection in here, which is an inline path, right? In this case, we just say, give me all the authors back. For that exists a book where there is at least one genre with the name fantasy. So basically, we only get values back for authors which have written a fantasy book. Right?
Holy banana. So as well as my mind being blown, from what we've learned from you over the past couple of episodes, what I'm also thinking is, yeah, this should resolve into maybe a nested subquery.
That's right. That's right. Give me a second. I will give you the. I just want to query the results real quick. So I will switch to the REPL, and yeah, we can do CDSQL, select from books, and in there, right, we had the, let's say, title as book, and then we had the author.
Mm-hmm.
We inlined it with an exists, and in there we had the exists books, another filter. And in here we could also say genre.name equals fantasy.
Yeah.
Then I have to make sure to close all those brackets in here. Then we have the dot notation, right, for inlining our results. And with the name, and we can also use the H in here, so a calculated element, which makes it even crazier. And what do we get back? We get a big list back, right? So you see, for the book Wuthering Heights, for example, there is no author name returned since the author of Wuthering Heights has not written one fantasy book at all.
Right.
And for the other authors like Brandon Sanderson, Richard Carpenter, we get results back here.
Yeah.
Right. So pretty cool stuff, I would say. So very powerful. And this gives you now the possibility to just, you know, prefix your paths without repeating all this stuff. This is the concept I think to take home with. So instead of writing all this stuff again here, and give me a second. I think I will copy this over to,
I think
to
it's
the
just
editor.
The wrapping from the changing width.
Yeah. So we had our select from books, right? And there we had the big path expression. And if we now wanted to select the H with the same condition here, then we would have to to repeat all this boilerplate code.
Yeah.
And
so instead, we can do the new construct.
And instead, we can just inline our element access here to get simpler access. What happened now? I wanted to send this.
Maybe we should start a new REPL.
No. It's
CDS.ql. There we go.
Yeah. So that's the same thing being returned, the same thing happening behind the scenes, but like the query is just grown a lot, right? So
what are we calling this construct again? In an inline.
It's an inline nested projection.
Nested projection.
So we can also simplify it to this, right?
Yeah.
Or that, I mean, we can do everything here. It's just another path expression, right? For example, like this. I think this should work as well, right? Only get name and age back of authors which are alive, which is only Brandon Sanderson in my data set. Good thing he is. So, infix filters, right?
Wow.
We also have obviously some examples in our CXL, so make sure to check this out. But it's very simple yet powerful, right? If we have a look at the syntax diagram here, it's just an opening bracket. Then we have an optional where, which is always implicitly given.
Right.
So,
okay. Yeah.
So what we could do, instead of writing author
where is alive,
where is alive equals true, and it's just the same thing, right? So I would just not do it in this case.
Yeah.
But
I think it has a similar level of clarity and simplicity as in CDL, where we can omit the define keyword, for example.
Yeah, it's implicitly given here. Or for tables which are compiled to HANA, they have like an implicit annotation which makes them a column-like table by default, but you could override it, for example, to have a row-based table instead. So it's nice to know, just to understand the concept, what's behind it.
Absolutely.
But the cool thing is here, it's just is a filter condition, opening bracket, followed by an expression, right? And if we then click to the expression diagram again, you can see what an expression is. It's everything in here. It could be a nested expression as well. You could chain it. You could use predicates, literals, functions, everything in here. Okay, so looks very simplistic at first, the infix filters, but it's a very powerful construct. And depending on the context used, it will be materialized into different shapes, I would say.
Oh, right? Nicely put, yes.
So, and there we can jump over to our model again, maybe to have a little example here. So, infix filter again, right? We could say date of birth later than 1900 name as author name. And then if we do a CDS build, why is it taking so long? It's never a good sign. Okay. So, and then we can have a look at the catalog service, right? So all we see in line 12 now is our author.name. So in the column itself did not change at all, right? But if we have a look at the left join, there we see, additionally to the on condition, which matches the foreign key, the infix filter is in this case mixed in to the on condition. In the on condition of the join, right? Which was the author date of birth is later than 1900. So,
is there a reason why the entire from clause is enclosed in brackets?
Well, there could be. I think we just do it out of. I think it would not be necessary in this case, right? But in CDL, you could also just do. I'm not sure if it works right now, but I could also do define my own joins, right?
Ah, right. Yes.
And if you have multiple joins, you have multiple roots, and then it's a good thing to group. And I think we are like defensive in here, right? You see, we have brackets everywhere, so it makes really much sense to have them, for example, in the on condition. As soon as we have another filter condition mixed in, you see, we just put the conditions into brackets so that we don't lose precedence here, right?
Yeah, exactly.
So,
there's no
if we would not have done it, right, then weird stuff could be going on, especially if we had like an or in our filter condition, right? We could say author date of birth greater than 1900, or something like date of birth is less than 1800, something like that, right?
Yes. So it was just that I couldn't, I couldn't imagine what else might be in the from, but yeah, you explained it nicely.
Right.
If in doubt, put a bracket around it.
Yeah, that's true. That's true. And I think we do it just for defensiveness reasons in here. So yeah. Pretty much it makes much sense if you have entity who as select from my genres, and then we can do a for example, cross join my books, right?
Gotcha.
And then we can say books.id, for example. So just to have so no on condition, obviously, for a cross join, right? It's just a Cartesian product here. So, okay. Now it wants something like this. So it's the last try I will give it. And we should have somewhere now the foo HTTP view. And yeah, now we have our cross join also here in brackets, right? So in this case, it makes sense if you have anything else here, because this is our route from to select from, basically. But yeah, for defensiveness, and in some cases it is even necessary, which I'm not able to produce right now.
Yep.
So cool. What did we learn with the in line 18 with our infix filter condition here? In this case, and I think this is a good example because the author is a 2-1 association, right? So you only want to select special authors in this case. Yep. Here, the infix filter condition is mixed into the left join, as we have seen in our books entity, right? Part of the left join. And infix filter conditions could also be put elsewhere and then probably materialize differently. So
yeah, so I guess having the infix filter here, this is the reason why we're getting nulls on some of the results, because we're still getting the books, but we just don't get the authors because the condition is not met.
That's absolutely true. Yeah. Yeah. So what we could also do is we could use infix filter conditions in the from clause, which is also a nice syntactic sugar variant, I would say, right? So we could, and I will use the where keyword now here deliberately. It's not necessary, but it illustrates my point later on. So we could, for example, only select those books where the stock is between 50 and 100, right? And then we get only those books back, obviously, and also make sure that it worked by selecting the stock as well. So they're all in the closed interval here. So good thing, it worked. And you notice that we now put the infix filter condition for the whole query at the from clause.
Yes.
Which makes it, in my opinion, nice to read. So think about it. Select from books, then where stock between 50 and 100, and finally the postfix projection. So very nice syntax variant, which I haven't seen a lot in the wild, but
no.
Maybe some of you will try it out now, right? And this was just where stock between 50 and 100, right? And if we now compare those two queries, the results are exactly the same And also, if we have a look at the transformed, at the normalized
Yep.
CQL, we obviously will see a from clause with the books. And then we select only those where the condition holds, right?
Yep.
So this time we use the where clause, and we can now compare that to the syntax variant where you put the infix filter in the from clause, and it just is
Surprise,
exactly
surprise.
the same. It is
Same.
exactly the same.
Yeah.
So you could obviously, you could also go ahead here and define other query modifiers, by the way. So no, not now. We could also say order by title, and then, yeah, ascending, for example,
Yep.
right? Which just gives us order by for our whole query, which is also a cool thing to know, right? So in this case, we have alphabetical sorting in here.
The combination of CQL and CXL is so expressive. I think that provides me with great joy, but also I have to think a little bit about exactly what do I want to express and how do I choose to express it.
Yeah, that's right. So you have to think about what do you want, and then maybe you can start simple, right, with the where condition, and then later on you maybe think, I want to just make it a little bit more conscious and refactor my model. And if you have those little syntactic sugar variants at the back of your head, you maybe are able to improve readability a bit.
Exactly, and improving readability allows me a little bit to bang the drum I'm banging at the moment, which is less code is better, pushing left or shifting left is better. So the more concise, the smaller the surface area, and the easier it is to read and reason about, the better. So that's why these constructs and these possibilities are so great.
So now we can combine two concepts we learned today. The one thing being the scoped syntax variant of the from clause, where we have a path expression in the from separated, right? We select from books. So maybe to reiterate, we select from books, and then we use a colon, an author, right? Which gives us, finally, we select from the authors, right, at the end. So, and how I read this here, this from path is from right to left, basically. That's my way of reading it. So select those authors for which there exists a books entity, right? So we actually select from the authors here, right? So now we get everyone back because everyone has written a book, yeah. But this is a powerful concept.
Because if we had an author in the authors table that we didn't have any books for, that wouldn't exist. That wouldn't be output.
Yeah. And we can obviously this example may be not to be useful in our example data set, but we can obviously spice up. We're talking about infix filters here, right?
Yep.
So we can spice up this query a bit by using a condition for the books. So we only want those authors which have, for example, written at least one book, or which the following condition holds true. And then we could say the good old stock between 50 and 100, right? So, and if we look at the transformed, the normalized CQL here, we get our where exists subquery. So we select from authors, right?
Yeah.
But only those authors where there exists a books, at least one book, which have that the author has written, right, with the on condition here from the association, and then also our infix filter condition with the stock between 50 and 100, right? So, and then our result set shrinks down to a few authors here.
Amazing.
So, and again, the query is very conscious to read. So only select those authors which have at least one book for which this condition holds true. And we can also go ahead now and obviously put an infix filter at the end of our from clause here. Maybe use it to order by name ascending, right? And then we get a different order here.
And what, I think you might have said this already, so I apologize, but what are we calling this construction again with the colon? What's the term we're using in the documentation or here?
Well, it's just another path expression, but we need to have we need to really differentiate between element traversal, right, from association to another element, or from association to association to another element. But if you think about our very first example here, I think I have it still in the schema.cds. There we'll see the colon notation again, namely for, in this case, we have the aspect constraint title, right, which we used. But we could also go ahead and say, for example, with the annotate statement, right? We could also say annotate books, and then we could try to say books.title with @assert, and then the compiler will give us here a warning, right, which says the artifact subcapire bookshop books.title has not been found. So you see the fully qualified name of an artifact, right, consists of the namespace in this case, which we have defined in line 3 as the sap.capire.bookshop, plus the name of the entity we used within this context, which is books for our entity. And if we now use the dot notation here, it tries actually to annotate an artifact called books.title, right? So, right, I will make the, I can make the warning go away by renaming the books here. So this just the namespace capabilities interfere with the dot notation here. So what you do, if you want to really point to an element of an artifact, you use the colon notation to let the compiler know this is really my subcapire.bookshop.books. Right?
It's basically that signifies the end of the scope, and sorry, the end of the scoped name.
That's right. That's right. Fully qualified name plus element, right?
Yeah.
So
and now you show this. I've seen this example before. Yeah, of course.
Yeah. So we are working currently on a CQL documentation, which is very much like the CXL documentation. And there we illustrate this concept a bit with some examples and also with some text. We can learn about fully qualified names and stuff like that. It's really not too hard to understand, but just something to know and be aware of. Yeah?
It's almost like a leaf identifier.
Yeah, I would say so. And this gives you the possibility to just sort of structure your model, right?
Yeah.
So and maybe to conclude here, right? So we had the service with the books, where we had our author, which is date of birth greater than 1900.
Yep.
This infix filter materialized into the join. In here we have a scope query which materializes in the where exists, and in there the infix filter will will be pushed down to the subquery, right? So in this time not a join, but a subquery. And yeah, so the infix filter condition can be used everywhere, right? But it depends on where you use it, how it is materialized. So, and then one thing to compare is maybe also the books, which we had extensively talked about last week, right? If we have an expand, for example, here, and if we look at the resulting normalized query, then you can see we have our columns array, which only consists of our expand, which is a subquery with a lot of columns in there.
Yeah.
Because we selected the wildcard. And then we have the filter condition as part of the correlated subquery for the expand, right? So I think those are the three variants where the infix filter condition is either in a join, in a where exists subquery, or in a correlated subquery for the nested rejection with the expand in here. So infix filter conditions you can use everywhere where you can use paths. Depending on the context, it will materialize differently. Yeah, and you can do everything in here. That's, yeah.
So I'm just maybe this is a stupid thing to say, but I've just thought the example you had where you just now where you had the order by
Hmm.
as well. Again, thinking this is not about shifting left, but thinking, oh, could I have that order by in a calculated element or an association like calculated elements in at the schema level? So I could say, for example, um, if I had from authors an association to many books, in that association definition, could I have an infix filter with an order by in it?
That's not yet possible, right? So there it's only possible to, because what we do behind the scenes, if we have like, for example, the non-seller the association like calculate element, we just rewrite the on condition of the books here.
Ah, right.
So
Okay.
if you would look at the season, really the on condition is just the on condition of the books entity here is just
It's literally
appended with an infix filter, right? So this is really a query level thing to do here.
gotcha.
And yeah, so we I think in episode 3 or so we had a question um, which was something like, can I use aggregates in calculated
Ah,
elements?
yes. Yes.
And I showed an example where it is possible. It was possible with the expand, and there we grouped by the order items, right, and summed the prices up. So it is possible to some extent, but only in the query level,
Gotcha.
right?
Gotcha.
So
Thank you.
working on that. But yeah, this is really a hot topic here, and really
Absolutely.
new stuff. So try it out, and if you wish for something, you can always ask us to implement it. Right? Go to CapJS database services and open a feature request. It's open source. Contribute your features even if you feel lucky. So yeah, and maybe to
Fabulous.
conclude this, also, right? We had in here, we selected only authors which have a certain stock in here. And just to illustrate, we can just chain those infix filter conditions as far as we want, right? So for example, we could say, hey, give me those which fulfill the stock condition, but also have at least one genre written. And I can, again, chain
Nested.
this,
Yeah.
right? But I will just say, hey, exist genre name equals
Fantasy. Yeah.
fantasy. And then the result set shrinks down
Yes.
further, right? So play around with that and yeah,
That
check
is
out
amazing.
our CXL and yeah, you can do a lot about it. I think the creativity is the only thing which stops you here. So yeah, make sure
Ab-
to try out infix filters.
Absolutely. What I want to do at some stage is go through and just write down these examples and just stare at them, because I think that's the way I and I think a lot of other people learn, just to see the possibilities here.
Absolutely.
Fabulous. So, Patrice, you're already a professional. I think you can feel when the time is coming to an end of the
Yeah.
session.
Yeah, I
Absolutely
give over
fabulous.
to you.
And yeah, so that was mind blowing as usual. Thanks to everybody who has joined. We've got one more part next week where you'll be wrapping up, Patrice, and maybe giving us a bit of a summary and whatever you want to tell us. We're grateful. So thanks everybody for joining. Thank you, Patrice.
It was a pleasure. Have a great
And
weekend, everyone.
I'm going to have a lie down now because my brain's full. So have a great Friday, have a great weekend, and I'll see you all with Patrice same time next week. Bye for now.
See you. Bye.